Do you know a fact? Finding information and sentiment in text, that is text mining, has become a billion-dollar industry. NLP, also known as natural language processing, is one of the most important part of life of a data engineer and a data scientist. We all have heard about Facebook analytics, data-driven marketing, or algo trading using sentiment analysis. So from sentiment analysis in Python to text mining in documents, this field of data analytics has found many hearts. And there's no doubt that NLP is becoming bigger day by day. And of course, no one wants to miss this boat. Do you? Hello people, I'm 𝐻𝐵𝐿 and I'm back with a new video and some new learning. In this video, we are going to build models on text and see how you can build classifiers based on text models using Keras Tokenizer. We'll start by extracting sentiments in text by converting them into numerical values and then make them ready for the neural network model. So let's go. Hold on. Watch this video till the end and there's a gift to all my subscribers. So, what is a text or a sentence and what's the sentiment behind them? As per Google, a sentence or a text is a set of words that is complete in itself,
typically containing a subject and predicate, conveying a statement, question, exclamation, or command.
So, a sentence has different words and all the words have some meaning, or I should say sentiments behind them. Now, in order to feed it into a neural network model or any other machine learning model and analyze them, we need to convert them into a set or an array of numbers. The big question is how to do it. We could take character encodings for each alphabet in a set. For example, we have the word wolf. A wolf can be a list like this, with 1 to be the value of W, 2 to be the value of O, and so on. But there's a problem here. We'll have the same sentiment for both of these words, wolf and flow, because both these words have same alphabets. Little Red Riding Hood is a European fairy tale about a young girl and a big bad wolf. Big bad flow. Of course, these two words have different meanings. So how about if we consider words? What if we allocate each word a different value? So for example, consider this sentence. This is financial programming with 𝐻𝐵𝐿. In this sentence, we will provide a different numerical value to each of these words. And the value will be same for the same word every time. Similarly, my next sentence is like this video and subscribe to Financial Programming with 𝐻𝐵𝐿, which of course you will do. It will be like this. The numbers of financial programming with 𝐻𝐵𝐿 will be same as before. Now that's a lot about theoretical knowledge. Let's see how to do it on Python. So I'm starting with Keras, which is the most useful and the most important library for deep learning. So from Keras.preprocessing.text, I'm importing Tokenizer. Tokenizer is the functionality which is used to convert a word or a text into a numerical number, which will then be used in the neural network model. In the second line, what I'm doing here is from Keras.preprocessing.sequence, I'm importing pad sequences. I'll talk about it in a moment. So our sentence is, this is financial programming with 𝐻𝐵𝐿. Second sentence was, like this video and subscribe to Financial Programming with 𝐻𝐵𝐿. I have added 2 more sentences in the list, which are, my name is 𝐻𝐵𝐿 and I am a financial programmer with exclamation mark. Then after that, I'm making the model. Model is equal to Tokenizer and then in bracket, numWords is equal to 100. Now what is numWords? NumWords, as per Google, it's the maximum number of words to keep based on word frequency. Only the most common NumWords minus 1 word, important thing, NumWords minus 1 words will be kept. What does it mean? It means that by providing a numerical value to NumWords, we are providing the vocabulary size in the model. So in this case, our vocabulary size is 100. Although we don't have that many words here, but still we have provided numbers is equal to 100. Warning: sometimes the impact of the number of words can be minimal on training accuracy, but huge in training time. So do use it carefully. Then we take the data and encode it using fit-on-text method of tokenizer. The tokenizer also provides another property, which is word index. It returns a dictionary that contains all words, or I would say keys, and its allocated numerical values. On printing words, we can see that we have a dictionary with all our words, or I should say tokens, with all their allocated values. You can clearly see that all the words have different numerical value. For example, financial has 1, 𝐻𝐿𝑃vik has 2, I has 15, M has 16, etc. Also, an important information here. Just focus on this dictionary. You can see that it has made all letters lowercase here. For example, financial was with capital F. Here it's lowercase f, and so on. Secondly, it has took out all the punctuations. For example, there's no comma here, there's no exclamation mark here. Now the next step will be to turn your sentences into list of values based on these tokens, which will eventually be used to feed into the neural network model, for which we use texts to sequences. Now let's print sequence. After printing, we have the list of different values. Just focus on these numbers. For same words, we have same numbers all the time. For example, if you see this one, which is this, the word this has the value of 3 here, and it has the value of 3 here as well, because the second statement is like this video. Similarly, for other words as well, the numerical value is same if it is repeated. Now let me talk about OOV functionality, which is out of vocabulary functionality. Suppose that we have a test text, which is, this is my YouTube channel, Financial Programming with 𝐤𝐵𝐵𝐵𝐵. And second statement is, I am 𝐤𝐵𝐵𝐵𝐵𝐵 the Shura. And if we pass this text into the functionality of texts to sequences, and if we print it, we can see that it has not converted the entire text into the numerical numbers. Clearly, it can be seen that it has skipped these 2 words, which is YouTube channel. Why? Because all other words were present in the actual sentence, but these 2 words were not present in this actual main sentence. That is why on printing sequence 2, we have 3, 4, 12, 1, 5, 6, 2. 3, 4, 12 is this is my, if you search it here, and 1, 5, 6, 2 is Financial Programming with 𝐤𝐵𝐵𝐵𝐵. There is no number for YouTube channel. How to solve this problem? Of course, if we had these 2 words, which are YouTube channel, in the main sentence, then we would have numerical value for these 2 words as well, right? But we don't have it. How to solve this problem? How not to skip YouTube channel, these 2 words, or any words which are not present in the main sentence? This is done by OOV functionality, which is out of vocabulary. On providing OOV_token while instantiating tokenizer and giving it a value of some text, here I have written OOV, then what it does is it allocates a value of 1. It means that whenever there are some words which are not present in the main text, in the main sentence, then in that case, it does not skip those words. Rather than that, it gives a value of 1 at those places. Now, at this time, on printing sequence 2, we have 7, 4, 14, which is this is my, 2, 5, 6, 3, which is Financial Programming with 𝐤𝐵𝐵𝐵𝐵. The numbers have changed because I have changed the code. And 1, 1 for YouTube channel, because 1 represents OOV, which is out of vocabulary token. Just to mention again, you can use any text here in order to represent the out of vocabulary word. Important information. You can use whatever you like here, but remember that it should be something unique and distinct that isn't confused with the real word. Bingo! We are now ready to feed them to the machine learning model. But wait, these lists have different lengths. That is, the first list has 6 numbers. On the other hand, the second list has 10 numbers. This can create problem later, as it may be hard to train the neural network model with them. So let's make these lists of same length by using our friend padding. Not this one, this one. It is achieved by putting the appropriate number of zeros before or after the sentence to make it of same length. In this case, we can see that I'm having a new variable which is padding is equal to pad sequences, which we imported in the second line if you remember, and then inside this I have provided sequence, and padding is equal to post. It means that it is putting zeros in the end, not in the starting. If you see the result of this by printing it, we can see that the zeros are put in the end. So if we write padding is equal to pre, then it will be in the starting. Max length is used to provide the maximum length of all the lists. There's no need to provide this parameter, but if I provide it, it will ensure that the maximum length of all the lists will be equal to the number that I provided. Now, if a sentence is bigger than the maximum length, then in that case, it will delete some part of the text. By providing truncating is equal to pose, it will delete from the end. By providing truncating is equal to pre, it will delete the text from the starting. In the end, we have printed padding, and we can see that all the lists have same length. In the end, we have zeros, and now this list is ready to feed to the neural network. Eureka! Our input data is now ready for feeding to the neural network, which I will cover in the future videos. This is used to do the sentiment analysis or text mining in documents. Pause this video for a moment and mention in the comment box which of these two will have more demand in the future. Sentiment analysis for algo trading or text mining in documents. I hope you have already written your opinion in the comment section. I will feature a few of you in the upcoming videos. Just to summarize, in this video, we looked at how to tokenize words, turning them into numbers, and using a dictionary to look up which word goes with which number, using text to sequences. Lastly, we used padding to make all these lists of same length. You could understand that I'm trying to explain a very complicated topic in a very fun way, which you will not find on any other YouTube video. So make sure you subscribe to my channel so you don't miss out any future videos. Now it doesn't work like this. I'm making a lot of efforts to make these videos, and I just want one like from your side. Just do like right now on this video and support me. I'm not going anywhere if you are not liking this video. Now the gift to my subscribers. If you want to get a free access to my Google Drive where I save all my codes, including this one, you can go to my YouTube channel and click on this button, which is access to my Google Drive, and then fill some basic details. I'll be using this email address to give the access of my personal Google Drive. I have saved a lot of codes over there. You can use all of them. It's free of cost and no copyright issues. I hope my codes will help you in future. So make sure you subscribe to my YouTube channel and click on that access to my Google Drive button.